Hey everyone, it's Mr. Canfield. We're doing 7-4, part 2, factoring out a greatest common factor. So if you didn't watch the previous video, this video might not make a ton of sense. It's interesting how sequence like that works, right? Okay, so let's look at an example, and we're immediately going to jump into a 3-term. Excuse me. Oh man, it's not that boring, Canfield. It's just early in the morning. Okay, so let's say we have 16x squared plus 12x minus 8. Okay, so we're going to try to factor a GCF out here. Well, so we're gonna have to find a common factor to all three of these. I see all of them are even. And a trap that people fall into is they say, oh, so my GCF is 2. It's not. So 2 does go into 16, it goes into 12, and it goes into 8. But does anything bigger go into all three of these? 3 goes into 12. Does 3? No. Okay. 8 goes into 16, and 8 goes into 8. Oh, but 8 does not go into 12. But 4 goes into 16, 4 goes into 12, 4 goes into 8. Now how about x's? With these two, you could take an x out of both of them. Oh, but that does not have any. So an x is not common to all three, so the GCF for this is just 4. Okay, so here's how we factor out a GCF. What we do is we put it out front of a parentheses, and we open up the parentheses, and inside the parentheses, we are going to undistribute the 4. So like, what needs to go here so that when I do 4 times that, I get 16x squared? What needs to be 4? What about here? 12x comes from 4 times 3x. And 8, well, minus 8 comes from 4 times minus 2. And then we're done. In the future, we're going to talk about potential ways to take this polynomial and factor. That's more complicated. We're not there yet. So that's one way to think about problems like this. Let's look at our next one. We're going to do about 5 examples of this. So let's see, 10x squared. No, 10x cubed. Ooh, fancy. 10x cubed plus 15x squared plus 8x. Okay, so let's try to find our greatest common factor. And I'm going to continue writing it over here to the side, though that is not something we're going to do for a very long term. It's just for today. So let's see, our GCF, well, with 10, 2 and 5 and 10 and 1, those all go into 10. 3 and 5 go into 15. Oh, so, and then 1 and 15 goes in. So it looks like 5 goes into both of those. Oh, but 5 doesn't go into 8. Let's see. Well, 2 goes into 8 and 2 goes into, but 2 does not go into 15. Shoot, it's nothing. So whenever this happens, the number of the GCF is just 1. You can even write a 1 if you want. But what about letters? This has x cubed, this has x squared, and this has an x. So if we look at that, what do they all have in common? They have 1x in common. These ones have extras, but together they have 1x in common. So our GCF is just 1x or x. So to factor this out, I always say I pull it out. That's a very common way. They'll say I pull the x out of the polynomial. And then if we go in and write it, we'll remove one of these x's. We're down to x squared. Remove one of these x's, we're down to x. And remove one of these x's, and we're down to just an 8, because it only had 1 to begin with. So here's a check for, did I really factor out the GCF, the greatest common factor? Do they have anything in common now that I've taken that x out? If all three of them have something in common, well, then there's more to remove. Maybe on the next example, we'll look at that. Okay. Let's look at our next example. Wait, I did here. Okay, there. Now there's some consistency with my formatting. All right. So let's say, let's look at like kind of a counter example to this. Let's say we have 10x cubed plus 15x squared plus 5x. So this time, so same example, just instead of 8x, now it's 5x. So an x goes into all of them. We already talked about that. But now, what's the greatest number that goes into all of them? Because now 5 goes into 5. So I actually can say 5 goes into all three. So if I put 5x out front, here's a trap people fall into. They'll go, oh, okay, well, oh yeah, so instead of saying, well, like, what's going to need to go here to get that final answer? Another way to do it is, what's 16 divided by 4? Oh, it's 4. So like, what's 10 divided by 5? Oh, it's 2. And then I've got 3 x's. I'm losing 1, so I'm going down to 2 x's. Then 15 divided by 5 is 3. I have 2 x's. I'm losing 1, so I'm going down to a single x. And that just goes away. And that is a lie that people fall into. However many spaces there are in the original problem, there need to be that many spaces in the parentheses. So something's going to need to go here. Because if we don't write anything, then if I was to multiply this out, I would get 5x times 2x squared. I'd get 5x times 3x, and that'd be it. And I wouldn't have this anymore. So what can go here so that I do 5x times it, and I get that? There you go. Another way to think about this is, well, 5 divided by 5 is 1, and x divided by x is 1. So there we go. All right, next example. Let's look at what can happen if everything is, change my mind. Okay. So let's say we have this. 3x squared minus 9xy plus 12xy squared. Okay, so let's try to find a GCF here. So 3, 9, 12. Is there any number that can go into all three of those? Sometimes it's really fast, like, oh, 3, there's only 1 that goes into it, and then itself. And 3 goes into 9, 3, oh, 3. So our GCF number-wise is just gonna be 3. And then what about x's? Let's see, I got 2 x's here, 1, 1. So they all have an x, so I can take an x out. And then I see y, and I see another y, and I see a y squared. Sure, so they all have a y. So when I go to factor out my GCF, I got my 3xy. And now I just divide, right? So 3 divided by 3 is 1. X squared divided by x is, so there's going to be a single x left over. And y divided by y is 1. So the only thing left there is the x. So now I bring down my sign, my negative. 9 divided by 3 is 3. X divided by x is 1. Oh, okay, so it's gone. And y divided by y is 1. So it's just a 3. That's all that's left. Then I'll bring down my plus sign. 12 divided by 3 is 4. X divided by x is 1. Okay, so x's are gone. Y squared and y. Okay, so there's 2 y's, and now there's 1 y, so there's only a single y left over. And this would be our factorization of that polynomial. Okay, so I think I think that's everything I want to handle now. Yeah, so you should be good to go do the assignment now. Cool, see you next time. Well, you know what I mean, because I won't see you because I'm not seeing you. That's what I get for doing common YouTube sign-offs. Let's instead say, I will talk to my camera and you will hopefully listen next time. Bye!